video, we're going to show you how to program an Emetron M20 power monitor to protect your pump. Now, as you can see, we already have our pump piped up and we already have our power monitor wired up. So let's get started.
First, let's go over the basics. To cycle through the various windows, simply press the next key. To adjust the values, use the plus and minus keys. And to confirm the selection, press enter.
The first step is to set the units that power will be displayed in. To do this, go to window 1, press and hold the plus and reset key.
By doing so, you can cycle through the different units. The options are horsepower, horsepower is a percentage, kilowatts, and kilowatts is a percentage. In this example, we'll be using horsepower. Once the units are set, we're going to navigate to window 5. Here you want to make sure that the pump is set for both overload and underload protection.
It should be set that way, but if it isn't, set it to over and underload protection and hit enter to confirm the selection.
There are 3 windows we need to program based on motor nameplate information. First, we need to look at the nameplate horsepower or kilowatts, in this example 1.5, and enter it into window 41. Next, we need to look at the nameplate again and find out the full load amps for the motor at the voltage the motor is running at, in this example 19, and we need to put that number into window 42. Finally, we need to look at the nameplate and look at the number of phases. In this case, it's a single phase motor, and enter that in window 43.
Once that's done, we need to determine the limits that we want to set. To do this, we're going to run the pump and deadhead it by closing the discharge valve. Normally you don't want to run the pump with a closed discharge valve, but for very brief periods of time, it'll be okay. When you do close the discharge valve, the power is going to drop off dramatically, and we want to look at the power monitor and record the lowest value we find. And now that we have our value, we can turn the pump off.
There are several conditions that the power monitor can be programmed to protect against. At the low end, there is decoupled operation, dry running, and deadheading. Of those 3 conditions, deadheading would have the highest power consumption, so we're going to set our low trip point about 10% above the power drawn when deadheading.
Since the deadheading horsepower was averaging 0.27, we're going to set the lower main alarm 10% above that, which is about 0.3 in window 14. In some situations, the pump could draw more power than the motor's nameplate power, so we want to set the high main alarm to be the motor's nameplate power. To do this, we go to window 11 and set that to be the motor's nameplate power. This will protect against an overload condition.
As the pump's flow increases, so does the NPSH required for normal operation. When the NPSH required falls below the NPSH available to the pump, it begins to cavitate, and as a result, the pump's power falls off. In situations where the pump could cavitate, set the high trip point to be 90% of the pump's peak power. This way, the pump will trip off before it begins to cavitate.
Now that we've programmed our limits, we want to make sure that the power monitor is going to do what it's supposed to do. To do this, we're going to turn the pump on and deadhead the pump, and the pump should turn off after a few seconds. If for whatever reason the pump doesn't turn off, don't keep running the pump. Turn the pump off and recheck your parameters.